In the previous discussion, we delved deep into the process of training a generative AI model. We explored the various types of generative models, from generative adversarial networks to variational autoencoders. We discussed the importance of data in training these models and how selecting the right model and tuning hyperparameters can greatly impact the final outcome. Now that we've refreshed our understanding of how to train these models, let's explore how to evaluate and deploy them. Evaluating a generative AI model's performance is more than just crunching numbers. It's about understanding what those numbers represent and how they reflect the quality and usefulness of the model's output. Take, for instance, the inception score and Frechet inception distance. These are two metrics often used to assess the performance of image generation models. The inception score measures the quality and diversity of generated images, while the Frechet inception distance quantifies the difference between the distribution of real images and the distribution of generated images. For text generation models, we often use the BLU score, which measures how closely the generated text matches a reference text. It's a useful metric, but it's not perfect. One of its limitations is that it doesn't account for semantic meaning or the novelty of the generated text. That's where metrics like diversity and novelty come in. Diversity measures the variety in the model's output, while novelty assesses how different the output is from the training data. These metrics can help us gauge whether the model is simply regurgitating what it's seen before or genuinely creating something new. But there's an important caveat here. These metrics are not one-size-fits-all. Their usefulness can vary depending on the context and the specific task the model is designed to perform. For example, a high diversity score might be desirable for a model generating creative content, like poetry or artwork, but less so for a model generating factual reports or technical documents. Moreover, these metrics have their limitations. They can't capture all aspects of a model's performance, and they can sometimes be misleading. For instance, a model that generates very diverse but nonsensical outputs would score high on diversity, but low on usefulness. So, when evaluating generative AI models, it's important to use a combination of different metrics and to interpret them in the context of the specific task and application. And let's not forget the role of human judgment in assessing the quality and relevance of the model's output, which we'll delve into in the next section. Remember, a model's performance is only as good as the metrics that measure it. So, choose your metrics wisely and never lose sight of the big picture. The ultimate goal is to create AI models that generate useful, high-quality, and novel content. Beyond metrics, human judgment plays a crucial role in evaluating generative content. Sure, numerical metrics offer a quantifiable measure of a model's performance, but they don't always capture the full story. This is where qualitative methods involving human judgment come into play. Consider user studies, for instance. They involve real users interacting with AI-generated content and providing feedback on its quality and relevance. These studies can prove invaluable in understanding how well the model meets user expectations and where improvements are needed. Then there's A/B testing. Here, different versions of content are presented to users, who then provide feedback on their preference. This method offers a direct comparison of different models or model settings, helping to fine-tune the AI to produce the most engaging and relevant content. Expert reviews add another layer to the evaluation process. Professionals in the field scrutinize the AI-generated content for authenticity, coherence, and alignment with established standards or guidelines. Their feedback can provide insights that may not be immediately apparent through other methods. All these methods underscore the importance of integrating human feedback into the evaluation process. While AI has come a long way, it is still a tool created by humans for humans. Its success ultimately depends on how well it meets our needs and expectations. As we can see, humans are integral in ensuring AI-generated content meets user expectations and ethical standards. Once evaluated, it's time to bring our generative models into the real world. To do so, we need the right tools and platforms that can efficiently handle the deployment process. There are several proprietary platforms like Google's AI platform, Microsoft's Azure Machine Learning, and Amazon SageMaker that offer robust features for deploying generative AI models. They provide easy-to-use interfaces, scalability, and security, making the deployment process a breeze. On the other hand, if you're looking for open-source solutions, TensorFlow Serving, Kubeflow, and ModelDB are just a few of the many available options. These platforms offer more flexibility and control, especially when it comes to customizing the deployment process to fit your specific needs. Also, orchestration tools like Kubernetes and Docker can be used to manage and automate the deployment of your models across multiple environments. Choosing the right platform can significantly streamline the deployment process. Before deployment, we need to optimize our models for efficiency and compatibility. This involves several key strategies. First, let's talk about model compression. This technique reduces the size of our AI models, making them more efficient to run and easier to deploy. Think of it like packing for a trip. We want to take only what we absolutely need, leaving the rest behind. Next is quantization, which involves reducing the precision of the numbers within our model. This can drastically cut computational requirements without significantly impacting the model's performance. It's like replacing a gourmet meal with a fast food equivalent. Not quite as fancy, but it gets the job done. Then we have pruning, which is all about eliminating unnecessary parts of the model, such as weights that have little to no impact on the output. It's like trimming a tree. We remove the dead branches to allow the healthy ones to thrive. Another key step is converting our models to be compatible with different hardware and software platforms. This ensures our models can be deployed anywhere, from high-end servers to mobile devices. It's like translating a book into multiple languages. It allows more people to enjoy the content. Finally, we need to scale our model inference to handle high demand and ensure responsiveness in production environments. Think of it as hiring more staff during peak hours at a restaurant. It ensures everyone gets served quickly, no matter how busy it gets. Optimization ensures our models are ready for the demands of real-world applications. Deploying generative AI models isn't just about performance and optimization. It's also about navigating the intricate landscape of security, privacy, and ethics. As we venture into this realm, we find ourselves grappling with potential risks, some of which include the generation of misleading or harmful content. This can occur when a model, trained on vast amounts of data, generates information that is false or misleading. It's a stark reminder that the output of our models is only as good as the data it's trained on. Then there's the question of data privacy. When deploying generative AI models, we must ensure that the privacy of the data used in training is upheld. This means implementing protocols that prevent the inadvertent disclosure of sensitive information. A further challenge lies in protecting our models against adversarial attacks. These are attempts to fool our models into making incorrect predictions or classifications, often with the intention of causing harm or disruption. To counter this, we need robust security measures that can detect and neutralize such threats. Beyond security and privacy, we also must address ethics. This involves implementing ethical guidelines and ensuring regulatory compliance. We need to mitigate biases in our models, which can lead to unfair or discriminatory outcomes. We must be diligent in ensuring that our models are used responsibly, in a way that respects human rights and societal norms. So you see, deploying generative AI models is a multifaceted task. It's not just about the technical aspects, but also about the societal implications. Security and ethics are paramount in the responsible use of generative AI. Post-deployment, the work of maintaining and updating our models begins. It's not a one-and-done deal, folks. You see, generative AI models live in a dynamic world. User preferences shift, new data comes in, and the model's performance may fluctuate over time. That's why continuous monitoring is absolutely crucial. Regular tracking of our model's performance allows us to catch any dips in quality or efficiency quickly. It's like keeping a health check on our model. But what if we notice a significant drift in data or user preferences? Well, that's where the concept of incremental learning comes in. Incremental learning is just like it sounds. It's about training our model to adapt and learn from new data without forgetting its previous knowledge. It's like teaching an old dog new tricks without it forgetting the old ones. But hold on a minute. What happens when we need to make updates or changes to our model? Version control becomes our best friend. It allows us to manage changes to our model systematically, ensuring that we don't lose track of what's been done. And finally, before we roll out any model updates, A/B testing is a must. It allows us to compare the updated model with the previous version to ensure that the changes do not degrade user experience or model performance. Continuous monitoring and updates ensure our models stay relevant and effective. So let's keep our models in check and remember, it's a journey, not a destination. In this discussion, we've covered the essential steps in evaluating and deploying generative AI models. From performance metrics to ethical considerations, each aspect carries its weight. This is Peter Ease, asking you to subscribe and return for our next discussion. Until then, keep exploring the world of AI.